All right, now that we've learned about activity series, we're going to move on to learn a little bit about voltaic cells and see how those work. So this is page 130 in your lab notebook. It's just continuation off of that activity series POGL. So this is going to be looking at how we can use those activity series to our advantage to get energy flowing that we can use to light light bulbs, to all sorts of things. This is a voltaic cell. The specifics behind it, I'll get into more in the next lesson. This is a salt bridge here. We will have a metal here, they'll be in a solution, and we'll see electrons moving through these wires, which will be able to read the volts up here. Okay, again, thanks to Dr. Tom Greenbaugh for making this simulation and putting it out on the World Wide Web for us to use. All right, so the very first one, we've got zinc. We're going to want to put it in zinc nitrate. The reason is we don't want that zinc to be reacting with anything, and so the best thing is going to be a solution where it's itself. Also, then it'll have electrons that it can contribute to or gain more of as needed, as you'll see here. Okay, so, whoopsie, I don't want copper and zinc, I want copper and copper 2 nitrate. There we go. So you want those to match. We're then going to push on. Alrighty, so you can see the voltage here. Important thing is keep in mind what the charge is. And we can see the electrons moving through. It's lighting up that little light for us. So this is how a voltaic cell works. On a molecular level, you can see that the electrons are leaving the zinc, making the zinc a +2 ion that's coming off. And so over time, you will see that this zinc solid will start to decrease in size. On the other side, we got our copper. We have these copper 2+ ions floating around in our solution. They interact with those electrons to form a solid and then, attach to our solid copper here. This will see an increase in size as time goes on. Okay, so I think, note the direction of the electrons, the directions of the ions are moving. So this one, the ions were coming off of the zinc. This one, the ions are coming onto the copper. And which way were the electrons moving? Away from the zinc or away from the copper? So note all of that stuff. All right, 5 and 6 I want you to think on and see if you can't predict what would happen based on what you learned from activity series in the previous lesson, or I guess it wasn't previous lesson because you're doing it all on the same day, but in the previous activity that you just did. Okay, so now we're going to do a variety of things. We're going to put some silver, so this is going to be filling in that table. Hopefully you stopped and thought about what you would predict. So I put silver on one side, putting copper on the other side, turning it on. All right, I want you to write down that voltage. Make sure you write if it's plus or minus, which direction our electrons are moving. And then if the silver or the copper is the anode, or if the silver or the copper is our cathode. Alrighty, so that's for that first one in the table. Next we're going to do silver and zinc. So we got silver and our silver nitrate and zinc and our zinc nitrate. Let's turn this on. Okay, go ahead and record your voltage and the direction of flow for those electrons. All right, I'm just going to crank through this. So next we've got copper in our copper nitrate and silver and silver nitrate over here. Okay, so we just kind of switched directions from what we did before. Okay, record the voltage and the electrons movement. Next we're going to be doing copper And did we just do copper and zinc? I don't think we did. Copper and zinc. Okay, write down those observations. This next one has silver on the left and copper on the right. Well, guess what? We did that in that very first one, so just write that again. We don't need to repeat that. That was an oops on our part. All right. On the left, we've got zinc in our zinc nitrate. And on the right, we've got silver. Wait a second. Where do you want to do copper? We haven't done copper, have we? I don't know. Maybe we have, in which case we're repeating. I can't remember. All right. Write down your observations. Something that's interesting, if you compare that to when you had the copper on the left and the zinc on the right, what do you notice? Again, those signs are important. All right, and then our last one, we've got zinc over here. And then we've got silver over here. All right, let's run this. Okay, so make sure you record all of those. You go through and decide which one is the anode and which one is the cathode. Okay, going on, most of these are just, I want you to sit and I want you to think about it. Number 10 is filling out that next table. So let's work through that table together. We're going to have copper on this side for each time, but now we're going to change the molarity. Now, all the experiments that we did previously was done with 1 molar of our copper 2 nitrate and 1 molar of our zinc nitrate. You can take the data, because it's not going to change, from the previous table and put that in for your voltage. So I'm going to jump to number 2, where we're doing 2 molar of the copper 2 nitrate, and then do our zinc in our zinc nitrate solution, and let's turn this on. Okay, write down your observation, make sure you have the sign. What is the voltage? Okay, now we're going to go down instead of up, and we're going to use copper again on the left, and zinc on the right. And we're not changing the concentration of zinc because, like good scientists, we want to only change one variable at a time. Right now we're changing the concentration of our copper 2 nitrate solution. Okay. Turning that off, we're going to do another one where we're just slowly decreasing the concentration. I guess it's not that slow. It's by an order of magnitude. So I know I've talked about order of magnitudes quite a lot with you all. Maybe not all of you are familiar with it, what it means. Order of magnitude means basically either multiplying or dividing by 100. So 1 order of magnitude is multiplying or dividing by 100. So this is 1 order of magnitude between the two. This is another order of magnitude. If you're doing it multiple times, from 0.1 to 0.001, that's 2 orders of magnitude. I divided by 10 twice. Anyway, random side note. Okay, this is the next one. So write down that voltage. Okay, we're turning that off. And then we're going to do our last concentration for the copper that's changing. Remember, zinc, we're keeping it all at 1 molar for now. Okay, write down that observation. Now, we're going to take a look at the change in concentration for zinc. So we're going to just keep copper at 1 molar for each of these, and now we can change our zinc. So let's do zinc, and we're going to do a concentration of 0.1, because we already did 1 molar with the 1 molar, right? Let's take a look at 0.1. So that would be an order of magnitude smaller, in case you're curious. Apparently I'm going to make this an order of magnitude lesson too. All right. So that looks pretty good. Let's do another copper. And copper. We're going to leave the concentration at 1 molar. Zinc and zinc. We're now moving on to 0.01 molar. It's an order of magnitude smaller than the previous one. Write down your observation. And then we'll do another setup with copper and copper 2 nitrate at 1 molar and zinc at zinc nitrate. And we're moving on down to 0.001 molar. Okay. So, those are all the data points that you will need to answer the rest of this POGL. Think about, increasing the concentration of the reactant. First of all, think about which of these is the reactant, which of these is the product. When we're looking at zinc and copper, so which one's which, and then based on deciding which one's which, we can then go on to determine if the voltage is increased or decreased based on the concentration changing. Okay, thank you all for watching this, and good job. You are all doing awesome. Keep up the great work.